Welcome. My name is Chris Timmer. Welcome to our May newsletter for Realization Technology News. And for this month's newsletter, what I thought I'd do is a couple weeks ago we did a presentation for Project Control Academy where we described what we feel is really the problem we're trying to solve in projects around resource deployment. So I'd like to explore that idea with you today. And in order to do that, I'm going to walk through kind of what is a resource deployment problem, what is the deployment problem we see today in projects that we're trying to solve, what is this thing I'm calling a deployment map, and then I'll leave room for questions and feedback. Of course, this will be on LinkedIn, and you can provide your questions or feedback in the comments down below, so that'll be helpful. So let's dig into this resource deployment problem. And what we find, with realization technologies we've been implementing around the world for many customers for several years, and we felt that we needed to describe this problem that we're solving. Of course, we know that we have delays and changes and limited capacity on resources on projects, and these all create issues. When we typically look at how organizations are trying to tackle these issues, project plans get developed. And how do they get developed? Usually, if there's no real project plan, like it's not a template environment, resource managers will get together, they'll plan out their portion of the project. They will plan how their resources need to be deployed or execute the work that's assigned to them. It may come together into some type of an integrated plan that the PM might bring together. But in execution, what we find is oftentimes those priorities won't all be aligned, and the overall project plan may not be easy to maintain or update, especially when there's changes and variation occurring in the project plan. So these resource managers will kind of rely on their own individual plans to help their resources manage priorities and get things done, which makes sense. But when that happens, then the coordination effort that comes from really having an overall integrated plan begins to break down. The normal mode of executing when we're thinking about how to improve things or attack these delays or uncertainty when they're happening in projects is to focus on how do we get that data, real-time monitoring, some risk analysis. How do we look at these changes and delays as they occur and solve them over time, right? This is where a lot of our continuous improvement effort on project lies. But what we find that is still unsolved in projects is what we call coordination losses. And these coordination losses are when the handoffs are not done very well between one resource group and another resource group. You may have one resource group working on one stream of activities while another resource group thinks another stream of activities is priority, so they'll break up their capacity across those streams. We may have coordination losses that occur from vendors, from outside entities, and things that need to be solved. In fact, there are some studies that say somewhere between 20 and 50% of time in projects is wasted or lost on these coordination losses, whereas on the changes and delays, it's estimated maybe 10 or 15%. So a real opportunity is to focus on reducing these coordination losses. In fact, if you try to think about the effort that's required to address changes and delays, problems we may have over here with changes and delays on a project, you have to have some type of an event, you get people together, develop a new solution, you have to train new people. So there's some time that it might take. Here on the coordination side, if we can do something quickly, we should be able to see these losses reduce much faster than trying to incorporate some big change into our process. So let's explore this a little bit, and I'm going to use, the end result of this coordination loss really is, the end effect is you're going to see kind of bow waves of work moving through the organization. Resource groups may be overloaded at one time, and so they're really working hard to get their work out, and then the next week or weeks from that, they're underloaded and there's not enough stuff for their capacity to do. Then a couple more weeks and they find themselves overloaded again. So you may go through these bow waves of work, which is really an indication that my coordination losses are occurring and adding up. So over time, we could find that either I'm waiting, the work itself cannot be done because there's work resources are busy doing other things, or the resources themselves are underworked and they're waiting for work to come to them. So those two things can happen, and that increases the coordination losses. And we have to do this across, kind of a multi-skilled project environment where we have different resource types that have to be applied to the project plan at the right place at the right time. Not just resource capacity, but also the managers, the experts, the coordinators, those people making good decisions. So our problem really is, how do we allocate these resources, including our direct resources, and prioritize the work in the world of uncertain world of projects. We're going to have delays and uncertainty. We know this is going to happen. So limited resources and delays or uncertainty that will impact the project. So we want to minimize these coordination losses as much as possible. Kind of makes sense. So that's our objective. And we want to do that within a project and across projects. So within a project, maybe a larger project with multiple streams of work, as well as across a project environment may have many projects going on with shared resource capacities. Okay, so let's explore this resource deployment map idea. And to do that, I'm going to walk through an illustration first. So this is going to be a simple network, simple plan. And I'm going to think of this first in the world of unlimited resource, so no limited resource capacity, so just the perfect world. So I have some blue activities that need to be done in this phase before I move to the next phase, do some green stuff, do some purple stuff. This may be a detailed design, which moves into a procurement phase, which moves into assembly or something like this. So I have two different streams of work going on, and unlimited resource capacity. So I have 4 blue resources I can start right away, a couple green resources if I need them, and so on. So if I look at the critical path of activities to complete this work, it's going to be 11, 7, 10, longest path of activities, and it's going to take me 28 days. Right? Simple. But I don't live in that world of unlimited resources, so I do have limited resource. So let me just try to simulate that here by saying I have only 2 blue resources, only 1 green resource, and 1 purple. So now I can deploy my resource capacity, 2 blue resources. I'll start 1 on this stream down here. We'll start at B3, since it's the longest path of activities using our critical path knowledge. And then I'll put my other resources up here on B1 because it's the next longest chain. So B3 will work the first blue resource will work B3, then blue B4, and B1 and B2 for the other blue resource. Only 1 green resource, so I'll get to G2 first. I could reverse these if I wanted to, but G2 then G1, and then purple, right? And it's going to take me 42 days, roughly. But this is critical path, and there's many options actually of how to apply my resource capacity here, especially the blue resource capacity. I could start running the B2s first before B1, but a better option is to work one stream before the other. And so what we're trying to do here is to work stream number 2, work this stream inside this box. So both blue resources are assigned to work stream 2. Once they're done with work stream 2, they can assign it to work stream 1. Now the first guy gets done after 6 days, so he can come out here, so there's a little bit of overlap. But work stream 2 works inside this box, 2 dots inside the box. We want to complete all that work together. And the idea here really is to get to the key integration points as quickly as possible. So if this is a detailed design going into procurement, or maybe an MRO environment where we're going from the disassembly into the inspections, I want to disassemble and get to the first inspection so inspection can start as soon as possible, right, in a focused way. In order to do that, I need to assign both resources down here. I can't break them up or scatter them between the first work stream and the second work stream. So I model that in my project plan. I draw a box around these tasks and say, hey, they have to happen together, and these 2 tasks have to happen together. And the overall duration I get is 34 days. Pretty significant, an 8-day difference in from the critical path, really resources spread thin here, and resources operating in a focused and finished way, getting to that key integration point as quickly as possible. So I didn't change any of the work content. I didn't change really anything except how the resources get deployed. Significant difference. So what we're trying to do in projects is create this deployment map in a way that gets us to the fastest cycle time as possible, and that means I need to get to those key integration points as soon as possible. Okay. Now we still have uncertainties. We have coordination losses due to tasks just taking longer. In this, on the left-hand side, you see the 3 plus 4. These are just extra days it took. I didn't plan on these days, but they took extra time. And so if I execute in this way over here, I'm going to get a critical path of 48 days. If I do the focus and finish one box at a time, one work stream at a time, trying to get to the green, that first integration point as quickly as possible, what I'll find is it's only 40 days. So 40 days to get there. And you also notice that the delays that are occurring over here, if I deploy my resources this way, scattering them, there are, by the way, 20 other options as I can schedule this. None of them are very good, except for the ones that I drew boxes around, one work stream before the other. You could do this work stream 1 before work stream 2, and you get an improved result as well. But over here, you'll see that the delays cascade before I get to G1. So the 4 plus 3 is 7, and those delays are all added up. Here, the delays somewhat cancel themselves out, and only 4 of those days progress further. So when I have uncertainty in my project, this idea of boxing around the like work before in order to get to the key integration points as quickly as possible is still valid, even better. So the golden rule here is to concentrate our resources around as few integration points as possible, because projects are a series of these points, right? And this is where the coordination losses occur. So the faster we can reach those points, the better. And really, this golden rule minimizes the impact of these delays, as we saw. It also simplifies planning. So when you think about what I have to plan in this under concentrate resources scenario, this box really is a task leading to the G1 task, leading to the purple task. Within this task, WS1, we call them dots, 2 dots inside there. So those dots combined become one task. So if I need to add something to this box, very easy to add another dot if I need to, but I need to take one away. And this is where the planning becomes simplified, because I can do that at the box level, rather than having to draw intricate dependencies between all the dots. All right. So let's explore this a little bit, a similar thought experiment, capitalizing further on focus and finish batches. What we see here, this example, is we have 3 work streams. There's a number of different tasks in these blocks. So blue leads into green, leads into purple. It could be, again, my detailed design, my procurement activities, my assembly or manufacturing activities, what have you, whatever those phases might be in the project plan. In this scenario, I have 3 integration points between the phases. I want to do one before the other. The colors denotes a major skill or a type of task difference. 3 work streams. These work streams are all in one single project. And I have enough capacity here, blue capacity, to work 1 work stream in 5 weeks. So this one I can do in 5 weeks, this one in 5 weeks, this one in 5 weeks. So really it's 15 weeks overall. Right, so I have a choice on how to deploy my resource capacity. Let's look at a couple of different options. The first option is I'm going to take my resource capacity and spread them over the 3 streams of work. So the blue resource manager might say, look, 15 weeks to complete all streams. But if I do them all together, there's some synergy. I can capitalize on some saved work time. I can do those all in 12 weeks. So I feel really good about doing it in 12 weeks. Maybe we can create even some overlap with the green because they can get started a little bit earlier. So there's some overlap. And this is typically how people will spread their capacity across multiple work streams, is spread my resources across the work streams and create some overlap to try to make up for some of that, right? So even the green, the original duration is 7 weeks, 3 times 7 is 21, so I can do that in 18 weeks, same thing with purple. So I come up with an overall duration around 37.5 weeks, and I feel pretty good, all right? One other option I might have is to do what we did earlier, draw those boxes around all the activities or the dots that need to be accomplished in the first blue phase. So the first blue phase is 5 weeks. I draw a box around that. It leads into my yellow or green phase, which also has a number of dots in it. 7 weeks, and I'm not trying to reduce this duration here now. So I'm just doing blue before green before red. And you'll notice for the next stream, blue can start after the first work stream finishes. I'm not scattering my resources. And the green can start after blue, and the same thing. Now, since the green is the longest phase, we are creating a stagger for the overall project on green. You notice that blue can start, but then we have some time where it doesn't really need to be done. Same thing on the back end. So these buffers are naturally emerged into the project plan. And by the way, we're finishing the project in 30 weeks, significantly less than 37 weeks. And all we did was change the structure around how resources are being deployed. We're creating this blue box, looking at the capacity it will take to do all the work in that box, deploying the capacity to that box, and that's really the decision that a resource manager might make on when that box is ready to be released. And then how those dots all get done inside the box, we can leave that to the local supervisors to organize that work, right? And what we see is we have an overall duration, which is much less. Capacity needs, well, we need less capacity, 30 weeks versus 37 weeks. Almost, 20% less capacity to finish the project in this mode than this mode. The critical path remains stable. The critical path up here, where is the critical path? Difficult to say. It's really kind of everywhere, right? I'm doing some work here, moving down here, moving back up, and so on. So the critical path moves around all the time, creating instability. So we really have a much more stable critical path in this bottom scenario. Better predictability and control, less changes. I can see the flow of work easier. I can also create some what-if scenarios, and I'll talk about that a little bit later. The data precision that's needed is not as precise, not so precise, right? I need to know at the box level, I have a pretty good plan at the box level with a good enough plan. At the dot level, it needs to be good enough to get me the box sizing and resource capacity required, but that's about it. I don't need to be so precise with data at the dot level. So what's required? Boxes and dots in one integrated project plan. We're going to stagger those boxes so we don't overload the resource capacity. We're going to control the start of those boxes, and we're going to deploy resources in a way that can complete the box, not the dots, but the box first. Control the start of those boxes. We're going to record the process or the progress at the dot level. So as people execute the dots, we're going to complete those dots, say, hey, this dot's complete, and that should roll up to the tier 1 box and change my duration or the cycle time that I need for that box. And buffers in the project plan will provide some forward-looking alerts. Are we completing work as quickly as I'm using the safety in the project? Okay, dot priority, if I'm assigning somebody to a dot priority, dot task or the subtask, then that priority will be inherited from the tier 1 activities. Hope that makes sense. So let me give you a quick example, and then we'll wrap this up. So phases and boxes, here's an example in an ETO environment where we have some phases that a project has to go through. Inside those phases, there may be those larger level boxes, we're calling them. So this is a detailed design phase. In there, we may have a couple features we're doing, integrating those, customer approvals, and so on. Those become boxes. And inside those boxes are a number of activities that need to be done by folks, right? And these may be cross-functional, maybe a single skill, it really doesn't matter. And how do we organize those? So this is what we call tier 1 level of the project plan. We have a phase that may be going through, but then within that phase, what are the large blocks? And then within those blocks, what are the smaller level activities that still need to be accomplished? So we still need to assign these to people. They still need to be worked. We have some options. The first option is to kind of build a small network inside the box. We can do it that way with dependencies. And the second mode is using this volume of work. Here you have 4 red dots, 25 hours, so 100 hours. If I assign 4 people, then the duration will be 25 hours. So it's one way to kind of add up the hours and divide by the number of resources I assign at the tier 1 activity at the box level. WIP is similar to that, only I have 6 tasks here, and I assign 2 resources assigned to it. So my stagger will be the first 2, then the next 2, then the next 2. So kind of WIP-based staggering. Okay, so those are the options. This is a quick example where I have the red are the tier 1 activities, blue here are the tier 2 or subtask activities. Here I have disassembly in this MRO environment. It's a fairly short, less than 2 weeks of disassembly. And I have all the areas of the aircraft that need to be disassembled. So all those are subtasks here. And the roll-ups from the hours and the subtasks roll up to the tier 1. I'm using volume of work, a type of structure here. We also use some focusing milestones within the project plan. Either, if I need to have some equipment coming from or parts coming from outside the project plan before I start a phase, then I will create a FOCIP point as a synchronization point for logistics. I also may have some long lead purchasing activities, may have some interim milestones for longer projects, multi-year projects. We'll put some milestones in instead of trying to use the project end for our method for projecting lateness. Okay, so those are focusing milestones are critically important. In the interface, the execution interface, we have users can see the box priority pretty quickly, the dot priority based on how we're structuring those dots within the box, and then the auto roll-ups back up to the tier 1 level. So these oftentimes will get either change from not started to complete. So we don't really necessarily need in-progress reporting at the lower level, but we do need in-progress reporting at the box level. And of course, that reporting will give us some projections for key milestones. Are we on track? Are we ahead or behind to either an interim milestone or the project end? How many days and so on. So we have some signals of whether we're on track or not on track. So the what ifs we need to perform during the execution of the project plan becomes simpler. So if resources aren't available as planned, if we have additional tasks to add, we can add them easier at the dot level rather than having to create new tier 1 activities with dependencies and everything else. If vendors can't deliver, we can change those dates forward as necessary. If the client requests additional scope, we may have to add a couple of dots. It's not too complex. What if we're running late and want to catch up? We can quickly analyze at the box level which boxes need to be accelerated, where we can apply additional resource capacity if necessary. Late projects on future inductions. This is also a key one. So if this project is running late, how is that going to impact my future projects going forward? So all that becomes simpler. Other advantages, we talked earlier about the difficulty of replanning, so that's reduced, and frequency and difficulty. We can grant vendors access to see just certain points in the project if necessary. Key data points within the local schedule can be exported to a higher level plan, like a Primavera plan for large government projects or so on. Rolling wave planning is more quickly enabled. Oftentimes in projects, we don't even know what's going to go in those future phases. So we can create the blocks. We have a good idea what the blocks are going to be, but what the dots are going to be, we really don't know. So we'll save inserting those dots for a later period, but the box dependency should be pretty clear. I think this is also a big point that resource managers, when we talk about resource deployment, I really want to make sure that I'm deploying resources at the box level and releasing that work when I have capacity to do it. So I release it at the box level, then allow local supervision to execute the dots. So that really keeps everything in sync. So to recap, in planning, we want to stagger within and across projects to the available capacity that we have, right? We want to group the light work in boxes. Many of these boxes will be multi-skilled, so we need one plan. We don't want these resource managers having their own plan. It needs to be one integrated plan, and it needs to be fairly simple to keep up to date, fairly simple to make sure we capture things in execution. So the simplicity is really paramount so that it can stay usable. We want a plan that's usable. So one plan. We have to break down this silo mentality of having individual plans for different resource groups. And we're going to structure the boxes and dots to get to those integration points as quickly as possible. right? In execution, we're going to follow the box priorities. Dots will inherit the box priorities. So if I got a assignment to a task manager at the subtask level, the priority of the assignment will be in the right order. We're going to assign resources to the box, allow local assignments to the dots, monitor and adjust the overall project performance to those key milestone dates. So that's really the process. So any questions, feedback? I'd love to hear some feedback, questions, thoughts, concerns. You can post them in the LinkedIn comments down below. And thank you very much for the chance to chat with you. And we'll be following this up with another newsletter next month. Maybe not a video one. You don't need to see my face, but appreciate you guys listening in. Thanks. Bye.